Hi, I'm Clint Scala. I'm going to be demoing the SCT with the QDH tensioner. Basically, we have our SCT assembly, which is consistent of a control panel, a hydraulic assembly with a low pressure and a high pressure stage. We also have a servo motor, servo controlled system. It's electrically and hydraulically driven. The main application for the tensioner is to drop on to a RPV stud, clamp on with the QDH mechanism, go to pressure, and tension the stud. Once the stud is tensioned, we turn this gear handle to tighten the nut on the stud, and then we depressurize, and your stud is tensioned. Main components, this model happens to be a two-stage model. You have your upper stage and lower stage, hydraulic cylinders and rams. We have a internal latch and unlatch mechanism, a hydraulic system again, which has a static piston, and the cylinder itself moves up and down hydraulically. Disconnect switch is a circuit breaker, no fusing. We have an umbilical that comes in with main power and communications, which is Ethernet based. And this is our turning mechanism to turn the nut onto the stud or spin the nut off the stud during detensioning. Down below we have a hoist control handle, which helps maneuver the tensioner into place. And it has controls on board for the overhead hoist. On the side we have spherical cutouts for the nut and the stud that's adjacent to the one you're tensioning, and they're on either side. That makes for clearance so we can get the housing over the top of the stud without any interference. What we have on our hydraulics, like we mentioned, is a high pressure stage, a low pressure stage. This is basically belt driven from our servo motor to our pump stack. The motor drives the pump assembly for low pressure and high pressure. What we have on board for feedback is we have a transducer back in here for feedback, and we also have on board the servo motor is a feedback loop that gives us speed, and the transducer gives us pressure. So this is basically a closed loop system. Little LED lights that shine down onto the vessel head, basically for helping with alignment. Once these tensioners are in the cavity, it's quite a dark environment down there. So what these will be is helping with aligning to the adjacent stud for positioning. Okay, we have a quick disconnect fittings. Basically, this is a dripless quick disconnect fitting. Once you disconnect it, there's no oil dripping out of the hose or the fitting itself. And they're very easy to go back on. You basically push them into place and lock them. This is our HMI, human machine interface, for the operator. It basically handles all the programming, setup, and operation for this tool. It is a graphics display. What we have here, we can basically have tensioner setup, sequencing tables, program pressures and manual pressures. We also have on board our nut signal button, our latch and unlatch, and our e-stop button. So if I wanted to go in and set up this tensioner, I would hit K1, and it asked me for a password. I put in my password, and it brings me to the main screen for this tensioner setup. This happens to have piston return, a puller bar system, and a nut signal system. It also has an EMS, electronic monitoring system. So basically we hit a K5 and we can turn that on. Then it gives our pressures, our max pressure, low pressure, how many steps, and low pressure time. We also have the control times and speeds for our pressurization system. And actually this also has a mode to change it from a slave to a master. Come back out. Now at this point we can go into manual pressures to pressurize the system. That would be a K8. I can go into either manual tensioning or detensioning. I'm going to go manual tensioning, K1. Now at this point it gives you the readout, the feedback of what's going on with this tensioner. Right now I could unlatch the system, meaning I'm bringing up my sockets, my split sockets, and I'm unlatching from the stud. Once I'm totally unlatched, I can pick this tensioner up and move it to another stud. Once it comes down on the next stud, we set it down in place, and then we latch on. The system is now moving down via hydraulic pressure, and it'll latch onto this stud. I get a good puller bar signal. It allows me to go to the next screen. At this point, I can build pressure. So now, my target pressure here is 5,000 PSI. I can go and hit F9 and start to build pressure. It gives me a feedback of actual pressure from our transducer, and she's going to creep up to, in low speed, to about 3,000 PSI, and then she's going to go to high speed. She's in a high speed mode right now, going to 5,000 PSI. These little indicator lights up here means I am at pressure, at PSI, and I am latched on. Once I'm satisfied and I want to release, I'm going to hit my nut signal button. It's going to give me a blue indication that I've hit my signal, and it'll tell me up here on my operator screen, you have your nut signal. Once that's accomplished, I can hit an F5 and release the pressure, and within seconds, I go back down to zero pressure. Up top, we have 3 of these cylindrical pieces right here. This is our piston return cylinders. Once the pistons have fully returned, we have a limit switch inside of here with a rod that goes down inside and touches the piston, and it lets us know when the pistons are fully returned. Once the pistons are fully returned, we can go on and pressurize again. What this also has on board is an overstroke limit switch, whereas if we're pressurizing and we come up too high and we're going to overstroke, this limit switch will act as an e-stop and depressurize the system. This big cylindrical nut is called a holding nut. This is basically what holds back all that hydraulic pressure on the pull system. When you're pulling, this is what's holding it in place. And this is also adjustable. It's on a big thread on the puller bar itself, and this is adjustable for the height of the studs that you'll be on. This handle up here is a fine adjustment for latching and unlatching. If you're finding that you're coming down and you're trying to latch on and you're not quite there, you may be point to point on the threads from our sockets to the stud, you would adjust this handle, raising or lowering that socket to get it into position to latch. Okay, we're on the side of the tensioner now. This is our low pressure manifold. This is where low hydraulic pressure comes in for our latching and unlatching and our piston returns. We basically have 3 gauges. Our low pressure setting gauge. We have a gauge for latch and unlatch, and we have a gauge for piston return. This is the manually bypass unlatching system. So this is going to go, this rod inserts into this assembly here, which is basically a manual pump that actually pumps hydraulic fluid in to unlatch the pull system. This is our main power feed coming in to each tensioner. It has 460 volt power and communications, Ethernet communications, coming into this main bulkhead fitting, and the fitting is basically clamped on to the body, to the housing body, and power is brought through. We actually have on board is the electronic measurement system, the EMS system we call it. We get a feedback on this tensioner happens to be on a test stud right now, and we have a reaction, we have a bar underneath that we can actually move and we can record. We're recording the actual measurement of the rod inside of the stud. We have a measurement rod that's going all through the pull system, all the way up to the top of the tensioner, where we're taking the readings with our electronic module. This is our electronic control enclosure. Opening it right here. Basically what we have inside is we have our main disconnect coming in, which is a circuit breaker. This is basically the brains of the system right here. This happens to be an electronic drive that basically also has the power of a programmable logic controller built on board. So what it allows us to do is save a lot of space with a drive and a PLC, programmable logic controller system, built into it. The drive is going to control the speeds out to the motor, whether we're going into low speed, high speed, we're going to stay at a certain pressure. All that information is being fed back from the motor. It's a servo motor, so we have all the information coming back to the drive for that. Some of the other items we have on board is a power supply, which is a AC to DC power supply for our peripheral devices like our solenoids and things like that, lights, our operator interface panel. We have a filter on one side, and then we have the fan on the other side, which basically transfers the heat out of this enclosure, keeps it nice and cool. All the inputs and outputs are basically plug and play. They're all pluggable to the side of the enclosure via Nutrix connector. Some of the items that are customizable for a customer, one is the housing, where some customers may have obstructions on their vessel head that we have to get around. We can basically do a lot of different things with the housing, whether it's cuts on the housing itself, in the back, on the sides. We also make, this happens to be a square housing, we make a round cylindrical housing as well that helps with getting in and out of certain situations. We can adapt to different stud heights and different stud diameters. These happen to be for a 7-inch diameter stud, but we have them for different size studs and also different loads. We can program whatever the customer's load requirements are, what pressures they need to go to, how many steps they have. The control handle, we basically, on this model, we have an up and down 2-speed, but we could do multiple speed where it may be 3-speed. And we can also do, if you have a tractor situation, maybe left and right, in and out, as well as the up and down. And we have an e-stop, emergency stop button on this control. This happens to be a 2-stage model, just for the pressure that the customer wanted to get to. We make a single-stage model, which is shorter, and it has only one cylinder and piston involved, and can have the same top plate. This top plate can also go on any QDH models in the field that may be using a different style pump. We can adapt this top plate to an existing system in the field, and we have done that. We can customize it to those tensioners as well. One of the main advantages of this system is that we can go to multiple pressures. If you have a pressure system where you want to go from a 5,000 psi, or you may have an intermediate pressure that you want to get to, we can program intermediate pressures, we can program it to low pressures, and we can program it to extreme pressures where we may be going to 12,000 psi, 10,000 psi, and we can adapt to your system. What we have here is our intercom system, which is basically a microphone and a speaker with the volume control. It also has an option for an optional headset. The customer that purchased this one, though, didn't want anything on their head for contamination purposes. So what we have is a push-to-talk system where I could push this button and talk into the microphone, and all the operators downstream on the other tensioners could hear me.